Most students find this confusing. How can 1 over 2 be equal to 3 over 6? They look different. But are they actually the same? Let's understand this step by step. In this lesson, we will understand equivalent fractions and how different fractions can represent the same value. This will be a conceptual foundation for upcoming lessons. Look at these fractions. 1 over 2 is equal to 2 over 4, and it's also equal to 3 over 6. How can different fractions be exactly the same? Are we changing the fraction, or just changing how it looks? Let's find out. Equivalent fractions look different, but represent the same value. That means we change the numbers, not the value. Let's understand this visually. Imagine a rectangle. First divide it into 2 equal parts. Shade 1 part. That represents 1 over 2, right? Now take the same rectangle again. This time divide it into 4 equal parts. Shade 2 parts. That represents 2 over 4. And now take the same rectangle one more time. But this time divide it into 6 equal parts. Shade 3 parts. That represents 3 over 6. Now tell me one thing. Is the shaded area different in any rectangle? No. It is exactly the same area. Why? Because we only changed the number of pieces, but we did not change the amount shaded. That's why 1 over 2 is equal to 2 over 4, and it's also equal to 3 over 6. Now, if you watch this slide closely, you will find another interesting perspective about equivalent fractions. And that is ratio consistency. Have you noticed that in all these 3 rectangles, the shaded area is exactly half of the total area of the rectangle? That means the ratio of the shaded area to the total area of the rectangle stays the same, and that is 1 to 2. So remember, equivalent fractions keep the same relationship between numbers. Let's see a real-life example of it. Suppose, in a class of 20 students, 10 are girls. The fraction of girls is 10 over 20. Now divide the class into equal halves. Now the fraction of girls is 5 over 10. Are these fractions different? No. Because both represent half of the class. In simple words, 10 over 20 is equal to 5 over 10, and it is also equal to 1 over 2. As a result, all of these represent the same ratio, that is, 1 to 2. We changed the numbers, but the proportion stayed the same. That is equivalent fractions in real life. This happens simply because we are either multiplying or dividing the numerator and the denominator by the same number. But, the real question is, why does multiplying or dividing numerator and denominator by the same number work? Let's look at 1 over 2. If we multiply this fraction by 1, what do you think the outcome will be? Of course, the same fraction. Because 1 is called the multiplicative identity. That means when it is multiplied by any number, it does not change that number at all. Now focus on this multiplicative identity. What if we replace it with a fraction of the same value, that is 1? It will not change the result, right? So, I am going to replace it with 2 over 2, which is technically equal to 1. Now, by multiplying the numerator by the numerator and the denominator by the denominator, we will get 2 over 4, which is still equal to 1 over 2. Now you know why multiplying the numerator and the denominator by the same number does not change the value of a fraction. Now let's think in reverse. Rather than multiplying, divide the numerator and the denominator by the same number and see what happens. Take 3 over 6 as an example. Now divide this fraction by 3 over 3, which is technically equal to 1. And we know that, just like multiplying, dividing any number by 1 does not change that number either. So, by dividing the numerator by the numerator and the denominator by the denominator, we will get 1 over 2, which is definitely equal to 3 over 6. Common mistakes that some students make. Never multiply or divide only the top or the bottom, or multiply or divide them by different numbers. Always multiply or divide both the top and the bottom by the same number. Now it's your turn. Find 3 equivalent fractions of 2 over 5. Pause the video and try. The answers can be 4 over 10, 6 over 15, and 8 over 20. All we did was multiply numerator and denominator by the same number. Equivalent fractions are very important. They are used in comparing fractions, adding fractions with different denominators, simplifying fractions, understanding ratios, and even algebra later on. Equivalent fractions are the hidden structure behind many math topics. Now you understand not only how they work, but why they work. To fully master fractions, continue learning related topics like fractions explained, converting mixed and improper fractions, simplifying fractions step by step, comparing fractions, adding and subtracting fractions, multiplying and dividing fractions, or browse the channel for the lesson you need. If this lesson helped you, subscribe to Core Concept Academy, where math and science become clear, simple, and logical. And don't forget to follow us on Facebook, Instagram, and TikTok. Thanks for watching. See you in the next lesson.